Let's go.
You're listening to Making Data Simple, where we make the world of data effortless, relevant, and yes, even fun.
Hello, podcast listeners. You're probably confused right now that like I'm a singer. No, I'm not a singer. I am your podcast host, Al Martin here. Thank you for joining us. Hope everyone is extremely well in podcast land, and thank you for listening. The topic we have today for you is AI. We always have data, right? And the foundation or entrepreneurship in tech companies. It's going to be a good discussion. Today, I have Dr. Eric Daimler with me. Eric is an authority in artificial intelligence. He's got over 20 years experience in the field. He leads MIT's first ever spinout from its math department, and he has co-founded 6 technology companies that have pioneered work in fields ranging from software systems to statistical arbitrage. As a presidential innovation fellow during the Obama administration, Eric helped drive the agenda for U.S. leadership in research, commercialization, and public adoption of AI. He's everything. I think you're everything, right? Entrepreneur, executive, investor, technologist, policy advisor, author of a new book. I think it's The Coming Composability, the roadmap for using technology to solve society's biggest problems. And then on his copious spare time, he serves as assistant dean and associate professor of software engineering in Carnegie Mellon School of Computer Science. There he focuses on the intersection of machine learning, computational linguistics, and network science. What about the definition of success when you're with the government helping drive the agenda?
Right. What I did and had the great privilege of doing is speaking on behalf of the president, humbly speaking on behalf of the president on what we wanted to accomplish across the executive. I most often worked with the Defense Department. I think some of the things that I can say at a high level were around determining the points at which we could detect foreign influence in any one of the suppliers that might make up a system that is integral to the functioning of the U.S. government. That's something that, again, bipartisan, everybody can get behind, and that was an important part of the job. Other jobs that related to AI that I had the good fortune of being involved in were around next generation air traffic control, and also in health and human services around and in veterans affairs in working with medical robots and the choices we'd have to make around collaborative robotics in those applications. We want to coordinate the spend from the U.S. government across those initiatives. Towards that end, the meetings we would have had been expressed in publicly available documents that are still excellent, and they're available on the White House archive, that define some of the goals that we set out for the federal government. I'd say since then, something that we can say is that that office, the colloquially known Science Advisory Group, now has a dedicated AI office. I know the people in that group and lead that group, and they're first rate. So I'm really, I think all of us can be really happy and even proud to have that leadership and that leadership elevated within the executive to give the president visibility on continuing to maintain leadership in this very important.
What happens? Does Obama call you up and say, Eric, you got to be part of the team, man? Come on up. We're going to work together.
Yeah. Yeah. Just to be clear, I wasn't in the cabinet. I wasn't even close to the cabinet. So
okay.
Yeah, that's not me. And no, I as much as respect as I had for President Obama, we were not beer buddies. I would love to be a beer buddy with President Obama. I don't think he would consider me to be one of his peers.
Give it time. Give it time.
Yeah.
Hey, I got one more question on that, though. You mentioned, look, we're the research in AI world leader. Good to know. The concern that I would have is China, in that do they stand to position themselves as maybe not the research leader, but in practical implementation of AI, can they or have they taken the lead? And the reason I ask that is because they may have the largest corpus of data to deal with. That gives them a lot more information to make decisions off of. Now, on the other side, back to your earlier thing, well, that could also be, I guess, a detriment if they don't know how to organize that data and get it set up for AI use. But is it a worry?
So the concern that China is just creating a lot of data, it may not be the right place to look. The current discipline of data science has been distorted by everybody getting the memo of collecting more data, because the expression often shows up as an executive asking for some magic to be had with this collection of data. The data scientists can often push back. No, I can't get anything out of this. And they'll say, well, great. Why don't I give you more data? That's not the answer. I'm not going to find a needle in the haystack if you then give me 2 haystacks. It's like there's some comic, I think it was in XKCD perhaps, where the person's in there, stirring with their pitchfork the big haystack, and they said something the equivalent of, well, if I just stir the haystack some more, I'll give you some interesting conclusions. So more data isn't necessarily going to be the problem. It's how we put this into use. It's how we collaborate among our allies. It's how we coordinate among broader society in how to express AI in practical, I'll say commercial, but it also applies to government applications. That's the place I think we would all benefit by focusing our energies, focusing our.
But does China? I mean, what is there a worry with you on China, or you say no? I don't concern myself with that.
I have quite a few concerns about China in many different vectors. And technology vectors, right? Many different areas around technology, so I can't say that it is not a concern. I'm trying to just focus on what is actually actionable for us, and what is actually actionable for us, where we can demonstrate leadership in America and in Western society is in focusing on how we apply AI. That is some advantage we have in having a more collaborative conversation about how we want to put this data to use to have people embrace it. It's not about just having the sexiest deep learning algorithms, which are fantastic. It's about how we then actually work with these technologies. Related to this is the idea of general AI, the consciousness about AI, that some people have a concern, or around the jobs that can get replaced through AI. Many of those problems can't be completely addressed, but we can at least take productive action in those regards by clearly thinking how we want technology to be applied, creating the circuit breakers around when we want people to be involved. We started in our conversation talking about snow with automated cars. That'd be an example of a circuit breaker where we need human intervention. Talking more about those circuit breakers is super helpful, both for jobs and for safety and AI consciousness. Also talking about data lineage and data provenance. Where did the data come from? How was it processed? Either in a clear, transparent way or in a zero knowledge proof through a black box, if that's what we determine is appropriate. And then, coordinating with the European Union and other allies on how we want these algorithms to show up is part of how we can address many of these concerns from the threats from China and just the threats we have from people resisting interesting and life-saving technology.
What would you rather discuss? You're the guest, so would you rather discuss your current company, Conexus, or the forthcoming book, The Coming Composability? What's your favorite topic?
They're complementary, so we could do either one.
All right, complimentary. So you started like 6 companies. Why 6? I mean, you keep finding gaps of where, this needs to be solved, this needs to be solved, and you create this and then move on. And then second part of the question is, all right, Conexus is the company of choice today. Can you tell me about what it does and the problems that it solves?
Sure. If I looked back, and this isn't necessarily how I planned it, I was just really fortunate to have a series of happy accidents between terrific business partners and a highly scientific, I guess, or highly sophisticated technical problem. That's generally just where I found a mix of my interest, my intellectual interest, and my ability to provide some value. So that's the commonality. That's the thread between everything that I have done. What I am doing currently is working to have the Institute tell it MIT's first spinout from their math department ever, and that presents its own set of challenges. The
Did
terrific.
They just get tired of dealing with you? Just say, "Hey, Eric, you're out. Go get something." Sorry to interrupt, but I get it.
Yeah, I'd say I would be the reject in the math department because I like whiteboards and they like blackboards. They are almost religious about their use of blackboards. It's really quite funny. One of my business partners, he really didn't even like using computers as much as I think he liked using blackboards. But these people have a level of knowledge and intelligence and a work ethic that is continues to inspire. I think that this effort around this math is something we will see more and more in the coming 10 to 20 years. You think of how long the framework for computers based on logic has persisted. With this new framework around composability, we're entering that new epoch. To distinguish composability for a moment, we can think of modularity. Often people will think of Lego blocks that I still enjoy. Lego blocks are terrific in giving examples of modularity. An easier one, like Lego blocks, is a train. You can swap in and out box cars as much as you'd like. That's a type of modularity. Shipping containers can be another one. The issue about trains is that they can only go so long. You can only have them, I think, just a couple of miles long before they start to lose effectiveness and you need to stop. Different than a train is the train system. For a train system, at any particular time, that can grow infinitely large. At any point in time, at any place, at any junction, you can grow the train system infinitely in any two-dimensional direction. That's a difference between modularity and composability. Many systems around us are emerging in their compositionality. Smart contracts are a good one. Quantum computers are another one. What happens with this math is we have to be able to analyze for effectiveness these increasingly complex systems. And when we have scale, we have complexity. So this is going to become more and more part of our world. What Conexus does, what my firm Conexus does, is we just apply this to databases. That's all. We just apply that math, and we apply the concepts of compositionality to databases. So whether it's 300,000 databases or whether it's the hospital system in New York that has a dozen or so databases using different definitions of diabetes, or it's a financial services company with whom we work that has a risk management function that finds it difficult to bring in databases from across the company on data that they've already spent resources collecting. bringing those databases to one system in a definitively reliable way, without guaranteed to be absent of mutations. That is provided by categorical algebra, and for databases, that's what Conexus provides.
So just to be clear on that, this is essentially data consolidation, integration, lineage. What is your secret sauce that you could say? What differentiate you from other companies doing integration, governance, cleansing?
Yeah, in the broad sense, data integration is the domain. That's a very big industry, we can call it, that consumes tens of billions of dollars each year. And that's maybe too big to talk about by itself. What we do, what Conexus does, Conexus automates a big portion of the data engineering task that often data engineers just don't want to do. We don't do the data cleaning. That's a precursor to any sort of data engineering work that we do. We don't create, we don't actually move bits. Those are complementary, and those are really interesting, terrific companies. What we do is we automate in a way that guarantees the integrity of the data transformation, any sort of data between databases. Our foundationally different approach is that we uniquely, and this is quite unique, literally unique, not figuratively, we can prove that the semantics, the meaning of the data and the data relationships, we can guarantee the integrity of the data and the meaning during transformation. That's fundamentally what Conexus does.
I get what you're saying in terms of the data relationships. At the same time, you said, "Hey, look, we don't clean the data. That's for somebody else to do to get it right before we jump in." But if you don't clean that data, I mean, the lineage doesn't matter when the data is all messed up to begin with. I mean, you walk in and you look at it first and say, "Guys, you got some cleanup to do. The foundation is not set. I can't build this on sand." Or is there a different way of looking at it?
Oh, it's a great question. No, data cleaning absolutely needs to remain part of the flow of work. We're not magic. We don't solve the problem or compete against any company such as Data Tamer that does a really good job of disambiguation or entity resolution or any other sort of expression of data cleaning. But we don't do that. Okay. What we will do, what Conexus does, is guarantee the integrity of data during transformations without ever even looking at the data. That's what we do. So we will be able to identify, for example, any sort of discrepancies between data sets that otherwise needed to have been integrated. We can, without moving bits, bring together multiple databases for analysis. It's complementary with really everything else out there. What we replace is a whole bunch of poor data engineers doing some manual code in Python or in using legacy software such as from Informatica or Ab Initio in many portions of that work.
That makes sense. Now, in your book, you talk about the coming composability, the roadmap for using technology to solve society's biggest problem. Everybody, all our listeners, I guarantee they're heavy readers, they're going to go buy this book. That's the good news for you. Now, what is the 2-minute roadmap that you speak of?
Yeah, the issue about composability, and the book will be released in 2023. So yeah, okay. To my publisher's dismay, but it is I'm trying to provide a way that people can be interacting instead of just giving them a good idea about what composability will entail in our society. So we talked about expressions of composability being quantum compilers or smart contracts like Ethereum. Those are examples of composability. Minecraft is even an example of composability. Now, if we look at emerging composable systems, a way to get there, a way to recognize it, and a way to participate in, we'll say, the composable economy is to begin to distinguish in the way that engineers, lawyers, accountants are often trained to be thinking with greater precision about implicit knowledge becoming explicit. An easy way to talk about it is showing one's work. So we all will need to show our work. We can start by thinking around heuristics.
That sounds like a professor.
Yeah. We can think about developing rules of thumb in implicit knowledge, and then as we begin to be comfortable with our rules of thumb, begin to put those in more formal structures, call those algorithms if you want, and those algorithms can then become part of larger systems that we then can just forget. They just got to go by the wayside or fade into the background, such as with Minecraft. We can enjoy Minecraft, but we don't really need to be thinking about the complexity of Minecraft that allow this infinite sort of expressiveness inside of it. Another one is maps. The sophistication of Google Maps today is really faded into the background, but is very hard to distinguish between the Google Maps of today and the mapping technology we had of, I think, was 25 years ago that Elon Musk started his first company, which was Zip2, a mapping company.
Yeah. So are you still involved with many of the other companies, or is it Conexus today? That's it.
I sit on the board of directors of two other companies.
Yeah.
I have advising relationships and investing relationships along many, many others. And I still have informal relationship with our government. And I hope to go back and be in public service again someday.
Public service, I presume it doesn't pay as well.
My wife pointed out it was the worst paying job I have ever had. Financially, I got a certain reward and satisfaction of serving the public, but financially, it's very tough.
So look, I got 3 questions left. But anything that I didn't say that you would have wished I would have asked on Conexus or your forthcoming book?
I can mention something about AI regulation, if that'd be helpful. If you
yes,
think that'd be helpful.
Please. Yes.
Okay. Around AI regulation, there are a couple of ways that we can begin to express our own requirements as a society, because we need to get involved in these conversations around AI. The first one we mentioned a little bit, but it's just worth distinguishing in the context of regulation, is circuit breakers. So the circuit breakers are a critical component of AI regulation, because right now what you'll have individually motivated product managers that will just link automation systems, link AIs, because they can. We want to, as a society, just be thinking about where we want automation to be linked. An example we talked about with snow with autonomous cars. Another one with autonomous cars is, as your car rolls towards a crosswalk and it sees something, is it a shadow? Is it a person? Is it a tumbleweed? Does the car slow down, keep going, or come to a complete stop? Those sort of conversations are one that we're going to have to get involved in about where we want human intervention. Call that a circuit breaker. The next is audits. We are getting a huge productivity bump from the implementation of these sophisticated automation technologies, I'll call them. We can discipline ourselves by taking off a portion of that beautiful productivity improvement and just doing an audit. Did your data model do what was intended? You can have that be audited by people that are experts in the field to be able to audit such things. That can start with the developers or the company separating the data from the data model and then declaring the intention of the data model. And then we'll audit, did that data model do what was intended? And then the last one is, we talked about this a little, we can demand that these systems have data lineage, that they maintain data lineage. You just saw today the president sign a bill around companies being required to disclose when they had a material data breach. We need to sign a law requiring companies to maintain data lineage. Where did that data come from? Let's have hyperlinks all the way down so that we just don't make up information around news or any sort of automation systems. So those three things: circuit breakers, audits, data lineage. That's my takeaway advice for all of us to get involved in the conversation around AI regulation. If we don't participate as a society, our individual city councils will do some tragic things, such as the city of New York somehow they introduced a bill in for the mayor to sign in I think it was November or December of 2021, I forget which month, where they were going to require employers to disclose to job applicants whether or not they used an automated system to review their resumes. It's just the silliest thing, because the definitions of what an automated systems is and how the different ways it could be biased, I don't think is really helped by just disclosing that there was automation involved. So I agree, we need to have a broader conversation of what sort of regulations we want around these systems.
We didn't even talk about bias, a huge concern, I would say, around AI today. I mean, but I'll give you a minute on that. Anything you want to say to? I mean, I think it is like in IBM. What we're doing is obviously we've got like technology that detects bias, explainability, etc. for that reason, to open up the black box, so there is no more magic. But any comments you'd have to that?
Bias takes many forms. We know of bias based on historical data, and that could be expressed as gender bias or ethnic bias or a national bias, perhaps. A bias that my company Conexus has been acquainted with is in working with companies to integrate their databases to report accurately on their efforts to mitigate climate change or other sort of environmental and social issues. What we find is that there is another type of bias that it goes underreported, we can say, which is the presence or absence of data itself. So we will be collecting and helping to integrate data on behalf of Conexus's customers. That data is more readily available within the developing world, within the US, within Europe, within our allies. But try to collect that data from developing countries that often have relationships with Conexus's customers, and it's harder to get. That's another type of bias that unfortunately then gets expressed in these reports to investors and customers and other stakeholders of Conexus's clients. So that's a bigger conversation around bias. Our efforts to mitigate bias will be directly connected to society's values, and it's important that we all just have a conversation about how we want that distortion to be mitigated.
But that's what worries me. Different societies have different values, which anyway causes issues. You had a PhD in computer science, right?
Correct.
If you were in school today, given all you've started with, you talked about categorical algebra, statistics, what would you major in? Or what would you advise those out there that are thinking of the computer industry, computer science, or previously computer science? Would you get in statistics? Would you do computer science again? I mean, any advice to those that could be in school right now, that are going to school?
I agree with what I said, that we're entering a new epoch that is going to be centered around composability. So yep. As I progress, I think, but it's a general rule, as people progress through computer science, we find ourselves studying math more and more. The math of my day was often focused around discrete algebra, discrete mathematics, and then morphed into being more about statistics and probability. I think today the math of categorical algebra is becoming clear as the next wave. That's where to be. Composable systems, I think, is a great place to be.
Fantastic. So look, they're the CEO of Conexus, right?
Correct.
You seem pretty technical, correct? You know where I'm going with this question. How do you manage balanced business while keeping your technology chops up to speed?
That's very kind of you. That's very kind of you. If you met my co-founders, I think you'd see the problem. Because they are far beyond me, and I am grateful to have them as my business partners. I am the least technical. I am just being responsible to our investors and to our customers, and doing what I can.
All right. But so how do you must keep up to speed. Do they keep you up to speed? Are there things you read? I mean, are you a constant continual learner? And are there any recommendations on what to read, when to read?
I think there is a lot of terrific places, but perhaps my go-to would be the Making Data Simple podcast. That's just a great place to keep current on the events of the day.
All right, good answer. I can't argue with that. Thank you for being here, Eric. This has been very informational. You lived up to the hype. Thank you so much. I appreciate it. And all listeners out there, thank you to you as well. Please let us know how we're doing. Reach out to us at almartintalksdata@gmail.com, and we will see you on the podcast. See you all later. Thank you.